Hello everybody. In this video we're going to talk about one of the ways that we can use in Matlab to do curve fitting. And this is kind of powerful way of doing fitting. It has more options than the least square curve fitting that we mentioned before. It can be used to fit data for lines and for curves and for surfaces and for anything. So it's very powerful. What we're gonna do is to go through the help, and I thought this is a good idea to go through the help and see how we can learn something from the MATLAB's documentation or help, because as I mentioned in a previous video, this is one thing that is important for the user to know, is to know how to find the information that he or she is looking for in the help by him or herself, without having someone letting him know how to do this or showing him how to do this. So what I'm gonna do is, or the function name that we're using is fit. So what I'm gonna do is type help fit, and then it's gonna show a lot of information here, but I personally prefer to open the reference page, which is a kind of user-friendly page that you can open and navigate by yourself, and there are some graphs and stuff that will help you have a good track of the information that you're looking for. So what we have here is the syntax. So it said the fit is fit curve or surface to data. The syntax is, there are many shapes of syntax. The first is the very basic one, which I personally like to start with because this is the simplest form, and then I can go to the more complex or more advanced shapes of the syntax one by one. And usually the rest of the lines will be the same with some additions. So here you have X, Y, and Z, and here you have fit type and fit options instead of just fit type. So again, I would personally like to go for the first one. From the previous work and from what we know, that when you do curve fitting, you need to define three pieces of information. First is the X data, second is the Y data, and the third is the equation that you want to fit your data to. So this is what we have here, X, Y, and fit type. So without even looking at the details in the bottom, we can kind of predict that this is the X data, this is the Y data, and this is the equation that I'm gonna fit the data to. And this is what we have here in the description. Fit X, Y, and fit data creates the fit to the data in X and Y with the model specified with fit type. So this is what we expect. The problem that we're gonna try is the equation that we solved before in the Microsoft Excel series, and the one I believe we solved when we used the least square curve fit in a previous video. So these are the X and Y data, and this is the equation. And we have already calculated everything, the A, B, and C, that fit well with the data, the R-square, and everything. So we know the results beforehand, so we can check afterwards. So now let's start. I'm gonna do or put the data that or the information that I have now, and one by one we will add more information according to what we learn. So this is what we have. The X and Y data are already there. Just make sure that you have them as columns, because the fit equation does not deal with rows. So I had them as rows before or in the first time, and then it gave me that error telling me that the fit needs to deal with at least one column. So I had here a lot of I mean the data has to be in columns, I'm sorry. So I converted them into columns instead of rows. And I'm gonna say that the results of the fit are gonna be the fit. This is the function. Again, it tells me the X, Y, and fit type. These are the same things that I saw here. So it's kind of nice that you can see the suggestions from here. So this is X, Y, and I'm gonna call it FT for now, and let's see what we're gonna get. So of course, if I run the now, it's gonna give me an error because it does not understand what's FT. I haven't defined anything that's called FT. And now let's go and see what is the fit type. Here we can see there are some cases. The first case, they use what's called poly2, and this is there are some built-in functions like the polynomial poly2, the second order polynomial equation, like the poly23, which is the second order in X and third order in Y. This is one type of equation, which is a surface, it's not a line. And there are others, but the one that I'm interested in is to define my own equation. And this is where I can find the example that fits with my needs. This is an equation that is y equals a multiplied by x minus b all to the power of n. So this is the equation, and I want to see how he defined it. I'm not interested in the fit options now. I'm gonna go to it in few minutes or later. And here what I'm interested in is the ft, and I just want you to notice how he defined the ft here. He said fit type and then put the equation. There are 2 points to keep in mind. First, he defined it as a string. It's not a function handle as we did in the least square curve fitting before. This is the first thing. The second thing is that he put them as a function of x. He didn't put the y. Y is not included here. And this is the way the fit type works. You have to put y on one side and the rest of the function on the other side. And this is what I'm going to do here. I'm going to say that ft is the fit type, and then define it as a string, and y equals a multiplied by x plus b divided by x plus c. And this is how Matlab or the help was defining the function. There are some other information here, but they're not very important, or not important or crucial to have it working. So when I run the file, it works, and it gives me some results, and we can kind of try to understand what the results are. So the first is f of t. It gives me that the model that I'm trying to fit is ft a b c x. These are the variables, and this is a x plus b over x plus c, and these are the results, which are the important part for me. From the results, we see that this is a 0.02436. B is 26.73, the same value, 1.568, which is the same value. So it's great. I'm now getting the results as I want. But I have here a warning that's saying that the start point is not provided. I have to, and they are the software chose random starting points. The starting points are the values of A and B and C that are initially put to start the iterations or the fitting with, and I haven't defined them yet. So to find this or to do this, we can either do what's called the fit options, where we can put start points is this, or we can put this directly in the fit type equation. So what I can do now is to put what's called start point. Make sure you put the S and P as uppercases because it's case sensitive, and I'm gonna put 1 1 1 or 0 0 0, whatever the values, and I run the file and it's working. I didn't see any warnings now. I have the starting points and I have the results as it did last time. And of course, if as the starting point gets closer to the results, it makes the solution easier and faster and more accurate, of course. Now, there is one other thing I am interested in, is to find how good the fit is. I now have the data, the results of fitting, but I don't know if it's a good fit or a bad fit. And the way we do this is by calculating what's called the R-square or the root mean square values of errors. And to do this, we can open the help, and we'll see that there is one other shape of the syntax that includes the GOF. GOF here, it's what's called the goodness of fit. There are many shapes of the or ways to calculate the goodness of fit, but let's see what we get. So I'm gonna make the output as a matrix, and this matrix is containing the results, which are the results and the goodness of fit, and I run the file now. The results are the same, and here we see the goodness of fit. It has the sum square of errors, which is 0.1134, which is this value, by the way. I calculated it already. This R square 0.9968, the same value. Then there are the adjusted R square, the root mean square errors, which might be of interest to somebody. So now I learned that I can define the equation in the fit type. I can define the initial points. I can define or I can make it fit the data. I can get the goodness of fit. Now let's say I need the results of the data fitting to do further calculations. For instance, I want to get the data from the value of A and multiplied it by 100 by add 10 to it, whatever the value. I need to do some mathematical operations to the results of the fitting, and I just simply say that, oh no, now he says this A is 0.02436, so I'm gonna do one more calculation, which is A plus 10 on the file, and I find this error that he does not recognize what is this A, which is surprising somehow to those who are not familiar with these type of results. If you take a look at X and Y, you'd see that this has the icon of the matrix, which means that it's a number that can be dealt with mathematically. But for FT, GOF, and results, they don't have this shape. FT is 1 multiplied by 1 fit type, results are 1 multiplied by 1 C fit, and GOF is 1 multiplied by 1 structure. The structure and fit type and CFIT are three shapes of what we can call as boxes, and each box contains the data as partitions. So to be able to get the results or the A from the results, you have to ask Matlab to get the value of A in the box that's called results. And to do this, you need to say results. This is the same, or the result, which is the same as this. Okay. And type dot, and then the part that you're interested in this box, which is A. So I can say that the A is the results A dot A, which is A in the results. So when I run the file, he now knows that A is a number which has the matrix shape, and you can deal with it mathematically. I can repeat the same for B and C. And now I know the values of A and B and C from the data fitting, and from the same thing can be done to goodness of fit. So I can ask him to give me the R square from the goodness of fit. So I can call this as R square, and now it doesn't have, oh, there is a missing S. So now I have the R square value. This is kind of a common thing that you can face in many functions in Matlab. The results are not as like separated. You have them all grouped in one package, like the results here and the GOF and the FT, and you have to ask Matlab to open the part of this box or the package that you are interested in, so you can use it in further operations. So there are more information and more details in the help. I just wanted to go through the basic or the important parts that I think they are of interest to most of the users. If you need more information, you can find a lot of examples here in the help, and it's going to be a good practice for you to do the surfing through the help by yourself. So I hope it helps, and I'll see you in the next video, inshallah. Goodbye.